Peter Chibero.
Let's humble ourselves for a word of prayer. Okay, let's pray. Dear Lord, we want to thank you for this day. We want to thank you for the gift of life. We ask you, Lord, as we are going to study, may you help us understand everything that is going to be taught unto us. We ask you, Jesus, to keep reminding us and to maintain us in a way that we shall always revise and remember what we are taught. In the mighty name of Jesus, we have prayed. Amen.
Amen. Thank you so much, Peter, for that word of prayer. We are going to start from that point such that everyone can be able to understand. Now, when we talk about trigonometry, I'm going to start from the other trigonometry you know. When I talk about trigonometry, trigonometry comes from the mathematical word tri and gono, which means three angle measurements. So in trigonometry, these are the things we are going to look at. So when you look at my screen, you can be able to see that for anyone who does the topic of trigonometry, these are the things you are expected to know. One, you are going to look at right-angled trigonometry. You are supposed to look at the ratios of special angles. You are supposed to look at sine, cosine, tangent of angles. You are supposed to look at the graphs, identities, equations, and then parametric equations. This is what is contained within trigonometry. So when you are dealing with trigonometry, you are expected to be able to do all those things under trigonometry. And now today, our focus is going to be on the right-angled triangle. And what does it mean when we come to a right-angled triangle? So your heading is going to be right-angled triangle, and then we are going to build up from there. So when you were looking at trigonometry, any math student, there are some things you need to know. And what are you supposed to know is to know what a right-angled triangle is. Under a right-angled triangle, we know that is any triangle that has a 90 inside. And for any, this is our angle and has a 90. But what is very important is for you to know how to apply that right-angled triangle. The moment you know how to apply it, then it means that at least you have a hint when it comes to trigonometry. Now, when I have a right-angled triangle, we know that any angle within this triangle, this is what we call an angle. And we are going to be using this letter. And this letter is a Greek letter we call theta. You're going to find it very common when it comes to trigonometry. But you need to know the sides of a right-angled triangle. Remember, this is 90. So where your angle faces, that side is what we always call the opposite. The biggest side or the longest side on your triangle, we call it the hypotenuse. And the side where your angle sits is what we call the adjacent. What do I want you to know? Is that whenever the opposite meets with the adjacent, you always form a 90 degree. Whenever opposite and adjacent meet, you form a 90 degrees. So in order for you to always identify where your 90 is always look at where 90 meets with another line. Where these two lines meet to form 90, one of the sides is either the opposite or the adjacent. Those two sides where 90 meets, one of them is adjacent, another one is the opposite. Then what connects them is what we call always the hypotenuse. And what are the three major trigonometric ratios? The three major trigonometric ratios, we are going to summarize them using what we call SOHCAHTOA. And at least I'm sure each of you, at least you have an idea from O level. That SOHCAHTOA, let me check. Can someone raise up the hand and you remind us what SOHCAHTOA means? Rachel, do you remember? Angel? Yes, Mary.
It means that to find sine, we use opposite out of hypotenuse, and to find cos, we use adjacent out of hypotenuse, and to find tan, we use opposite out of adjacent.
Wow, thank you so much, Mary. That's what it means. And if you are to succeed in the topic of trigonometry, make sure you know these ones. Opposite out of adjacent. This is the main thing. That sine, we get opposite out of hypotenuse, cos adjacent of hypotenuse, and tan opposite out of adjacent. These are the major ones. Then from these three trigonometric ratios, we can be able to obtain other trigonometric ratios. And this is where we are going to build now onwards. So at O level, you only looked at those three. But when you reach A level, we look at others. So others are always derived from these two. So these two are the ones that are going to give us other trigonometric ratios that we are going to be applying. Okay, you let me know. Can we move on? Are we on the same page? You can unmute and tell me. Are we on the same page?
Yes.
Yes.
Okay.
Yes.
Okay. Okay. Now, after understanding that, we have what we call other trigonometric ratios. And those other trigonometric ratios come from the reciprocal.
Yes.
Okay. Comes from the reciprocal of those ones. So one of them we are going to deal with is the tangent function. So the tangent function. So the tangent function, like I know most of you know, it is tan. But what happens when you have the reciprocal of the tangent? What happens when you have the reciprocal of sine? Now, those people who have not yet learned trigonometry, I want you to tell you that whenever you have 1 out of sine of any angle, let me say angle A, 1 out of sine A, we call it cosec. When I have 1 out of cos of A, this one, we call it the sec. And when I have 1 out of tan of A, this one, we call it the cot of A. These are the three new ones that we are bringing on board. Others will come from here. But I want you to take note of that. That whenever I meet 1 out of sine, that is the same as cosec. I meet 1 out of cos, that is sec. 1 out of tan is the same as cot. Kindly let me know whether we can move on.
Yeah.
Can we move on?
Yes.
Are we on the same page, member?
Yes.
Yeah.
Yes.
Okay. Have you written?
Yes.
Okay. Okay. Now we are going to look at the important thing, what we call the trigonometric identities. Okay. An identity is something that defines who you are. So in trigonometry, I'm going to use a right-angled triangle again. When I have a right-angled triangle and I have here my angle as theta, we know very well that this axis, we call it the x-axis, and this one we call the y-axis. So you are going to allow me to put here my R, this is my A, this is my B, and this is my C. Are we together on that? Someone raise up the hand and you tell us, in case I want to find sine theta, remember your SOHCAHTOA. So sine theta, members, what is it equal to? I want you to give it to me in terms of y, r, and x. Members, we can talk. Sine theta will be equal to, okay, Mario. Okay, y out of r. Good. Marion. Oh, sorry, Mary. What is cos theta equaling to? Mary, unmute.
X over R.
X out of r. Good. Then the last one. Who wants to tell us tan theta? What is tan equal to?
Y over R.
X over Y.
Y over X.
It is x out
Y
of
over
y.
X.
over X.
Y over
Y.
X.
Okay, it is y out of x. Okay, yes. So let me hope everyone y out of x. Now, I want you, when we come here, we can make our y the subject of the formula. Members, do we agree that y is the same as r sine theta? When you multiply, is that fine?
Yes.
Yes.
Okay, tell me members, what is x equaling to? What is
R
x?
cos theta.
R
R
cos,
cos theta.
R cos theta. Is everyone seeing that?
Yeah.
Are we seeing the trigonometry well, members? Okay. Now we are going to continue. Now, I want you to remember what we call the Pythagoras theorem. Pythagoras theorem tells us that when you have a b squared plus bc squared, members, it will equal to sc squared. Is this step fine? When I apply Pythagoras theorem, that when I add this side plus this side squared, these two sides squared, I'll always get this side squared. Is that fine? So,
It's fine.
okay. So A to B, according to my length here, is x squared plus BC, which is y squared, is equal to r squared. Members, are we together on that?
Yes.
Now, we are going to come back here and we substitute. We had our y as r sine theta. So where there is y, we shall put that. Where there is x, we put r cos theta. So I'm going to come here and I say this is r cos theta, everything squared, plus y, which is r sine theta, everything squared is equal to r squared. Now, when I come here, members, you need to remember that r cos theta times r cos theta. That is the meaning when we have a squared. So r times r is r squared. Cos theta times cos theta is cos squared theta. So members, here we shall have r squared cos squared theta plus, members, what shall we have?
R squared sin theta squared.
Sine squared theta is equal to r squared. Now, what will happen is that now r squared is common on both sine and cos. So meaning that when I factorize out, I have r squared into cos squared theta plus sine squared theta is equal to r squared. R squared being common on both sides, I can divide by r squared, I divide by r squared. So members, I remain with cos squared theta plus sine squared theta is equal to 1. And members, this is an important identity. Have it on your head. It is one identity that you never forget. Members, are we together on that?
Yes, sir.
Yes, sir.
Okay. Okay. So can we first write? When you finish to write, you type in the chat that we can continue. I've disabled the microphones. So after writing, tell me that in the chat, we have finished, we can continue. That identity is very important. It must be in your head. You must move with it. Cos squared theta plus sine squared theta will always equal to 1. Whether you are sleeping or what, the moment they wake you up, you must have that identity. It is that identity that we shall use to derive very many other identities. So it is an important identity. So I'm waiting in the chat. Mary is saying continue, patience, continue, please pardon. Okay, Malisha, I'm going to pardon you. Alicia, okay, we wait for more 3 people to say they are finished, and then we can continue. Okay, so I think members have finished. Okay, good. Now we are going to continue. Now, we have said that whenever we have cos squared theta plus sine squared theta, we must always come up with a 1. Now, what happens is, oh, Stella is saying, pardon. Okay, Stella, kindly let me know. Where is Stella? From which point and Patience? Stella, unmute. And Patience, before we continue. Patience, unmute. Yes, Stella?
So from the substitution of
Stella, go on.
r cos squared theta. How you substituted? I didn't get that part.
Okay. Yes. Did you understand how we apply the Pythagoras theorem?
Yes.
Then from here, Stella, did you see that this was x? Yes?
Yes.
So you come here where you have x here, you substitute r cos theta. You come where you have y, you substitute r sin theta. But here now the beauty is that what you have to know is that, let me see whether I can remove this. So here from that point, Stella, what you have to do is that now you have x squared plus y squared is equal to r squared. But your x is r cos theta, so you have r cos theta. But everything is squared plus y, which is r sin theta. Everything squared is equal to r squared. Hope that is okay, Stella. Stella, I want to move with you. Is that fine?
Yes.
Now, this statement means r cos theta times r cos theta, that multiply it twice. This means r sin theta times r sin theta is equal to r squared. Now, when you reach here, you have r here, you have r here. R times r is r squared. Cos theta times cos theta is cos of squared theta, plus r times r is r squared. Sin theta times sin theta is sin squared theta is equal to r squared. So when you check through, r squared is here, r squared is here, meaning it is a common factor. So I can factor it out. I get r squared into cos squared theta plus sin squared theta is equal to r squared. Now when you reach here, r squared is the common factor. So I divide by r squared, I divide by r squared. So this one and this one will cancel. I remain with cos squared theta plus sin squared theta is equal to r squared cancels, so you remain with 1. So that's how we have come up with that. Hope it is clear now.
Yes, teacher.
Okay. Now we come at this. Kevin, I'm going to slow down. Now, when it comes to this point, I'm going to apply another one. Imagine I'm dividing by cos squared theta. So in case I divide by cos squared theta throughout, I divide by cos squared theta, I divide by cos squared theta. Now, what is important is for you to remember is that what is 1 out of cos? What is 1 out of sine? So I'm going to come back and I remind you. We say that when I have 1 out of sine of any angle, this is what we call the cosec of theta. When I have 1 out of cos of any angle, this is what we call the sec of theta. So now when I come here, cos squared out of cos squared is a 1 plus, you remember we said that tan theta means sine theta out of cos of theta. So in case it is squared, then it becomes tan squared. So here we'll have tan squared theta is equal to 1 out of cos is the same as sec. But since it is squared, we shall have sec squared theta. And now this one gives us the second identity. Members, type in the chat whether you have understood that. Just say yes, yes, and we see whether we're on the same track. In case you have not picked it, you let me know and we repeat it. With Samoa is saying no. Okay, no sir, no sir. Okay, I repeat. Now, in order for us to get the second identity, we are going to ask ourselves the different identities that we have. But like I told you at the start, there are some key things you need to know, and one of them are these things we have here. What do we have? What I have is to know that 1 out of sine means cosec theta. In case what I have is 1 out of sine squared theta, this one will become cosec squared theta. In case I had cubed, this one will become cosec cubed. In case I had power 4, it will become power 4. So when I have cos squared out of cos squared, it's like having x out of x. Your answer is 1. So here we shall have 1 plus sine squared theta out of cos squared theta is equal to 1 out of cos squared theta. But what is important now to know is that you need to remember that whenever I have tan theta means sine out of cos of theta. So whenever you meet sine out of cos, what you get is tan. So in case it is squared, it means we shall have tan squared theta is equal to sine squared theta out of cos squared theta. In case it is cubed, it becomes cubed. So now here, I'll have 1 plus. If you want, you can even say this is sine theta out of cos of theta. Those who want squared, it means the same, such that you can be able to figure that sine theta out of cos theta is tan. So you get 1 plus tan of theta squared. But tan theta squared means 1 plus tan squared theta. This is the alternative you can do. Still the same thing applies here. You know it's the same as 1 out of cos theta, everything squared. But 1 out of cos theta is the same as sec. So here you get sec theta, everything squared, which will yield for us sec squared theta. Now this is the second identity. Members, let me know whether now it is clear. Is that fine now, members? Okay, then, okay. Okay, it is now clear. Okay. Now, we are continuing first, right? And then we continue. Yes, but in case you don't get it, it is clear. Because we shouldn't leave you behind. The moment in trigonometry you fail to know the identities, every part is going to be hard. You'll find a lot of hardships going forward. Now, we continue. This time round, to get this identity, we divided by cos theta. Now, what happens in case we don't divide by cos and we divide by sine? What will happen? Can everyone first try that identity? I'm going to show you the identity and then you try for me and we see what we get. Remember our identity is cos squared theta plus sine squared theta is equal to 1. Now, what if we divide through by sine squared theta? By sine squared theta. By sine squared what? Theta. Can you first try for me? And you see, do it the same way we have done and we see whether we get the same answer. Let me say. Yes, Davis.
Excuse me, sir. Can you please first reshare this screen?
Which one? That one?
This exact one. No, this exact one now.
That one, the green one.
Yes, the green one.
Okay. Finished?
Yes, I'm finished. Thank you, sir.
Members, I want you to follow the same steps Okay, Dila has got something. Yes, Haka, I know you have not studied, but you pay attention. Yes, Nelly. Yes, Nelly. Nelly is not talking. Yeah.
Sir?
Yes.
Yeah, I've got the answer here.
Okay, what do you have?
I have cot squared theta
Cot squared
plus 1
theta.
is equal plus 1 is equal to cosec squared theta.
Okay, thank you. Stella, what do you have?
I have the same.
The same. Okay, good. Good. Members, that is very fine. Members, still those who are new to trigonometry, we know that cot theta means cos out of sine. So for this case here, it will mean cos theta out of sine theta squared plus sine squared out of is 1 is equal to 1 out of sine theta, everything squared. And what does this one mean? Cos out of sine is cot theta squared plus 1. 1 out of sine is what we call our cosec theta, everything squared. So in your conclusion, this becomes cot squared theta plus 1 is equal to cosec squared theta. That identity is very important. Members, are we on that point, everyone? So when you finish, you let me know. It seems members are finished. Seems members are finished. Okay, that is good. So what are we going to do? Now I'm going to take you and we look at what we call proving. Oh, yes, I'm going to first take you now to proving of those trigonometric identities. That is going to be now our focus. How do we prove? That is where I'm going to take you, what we call proving. Oh, sorry, let me not use this pen. Okay, so your heading should be proving of trigonometric identities. And once we understand, it will be our focus for this lesson. Proving of trigonometric identities. Now, what does it mean whenever they tell you to prove? Whenever they tell you to prove, it means that they want you to come up with what they have given you. And proving, you can come from either sides of your thing. You can either come from this side or you can come from the other side. So we have two hands. We have what we call the right hand and the left hand. So when we tell you to prove, feel free or either to come from the left hand to the right hand or right hand to the left hand. But always there is one side that is easy and there's another side that may be a bit tough. But for you always do not fear. Try from whatever side you want. So the first one, number 1, we are going to prove some identities. Sec theta plus cosec theta cot theta is equal to sec theta cosec squared theta. That is the first identity we want to prove. Is that true? Now, what do you need? You need the mathematical eye. That is the one thing. Two, you must practice. Yes, I'll tell you. You need to practice these identities. So what are we going to do? So what we are going to do is something very easy. This is what we are going to do. Now, we know that sec, you need to remember them, that sec is the same as 1 out of cos of theta, plus I know cosec is the same as 1 out of sine of theta. I know cot is the same as cos theta out of sine of theta. Kindly let me know whether we're on the same page. Members, are we on the same page? Kindly let me mute. Are we on the same page?
But
Yes,
teacher,
Mary.
there you have written theta, not cos theta.
Where?
After cosec theta.
Yes. Now it comes from this side that cot means cos out of sine theta. Cos theta out of sine theta. So whenever you find cot, you replace it with cos out of sine. Okay.
Excuse me, sir.
Yes.
What if I put one, for example, for cot theta, I put 1 out of tan theta?
Yes, it is also okay.
All right.
Yes, yes, but you must know where you are heading. So when you put 1 out of tan, yes,
Yes.
when you look at where you are heading to the right hand, you ask, is there any tan there?
No.
So meaning now you need, but you can have that as your second step, then you substitute. Is that fine?
All right. Yes.
Okay. So this will become 1 out of cos theta plus 1 times cos theta is cos theta out of sine theta times sine theta is sine squared theta. Hope you're on the same page, members. Are we on the same page?
Yes, teacher. Yes, sir.
Okay. Now, what are you going to notice? We are going to obtain our LCM. Our LCM is cos theta sine squared theta. Alternatively, let me use this approach and I see whether some of you know it. When I'm getting the LCM, I'm going to remove. I want to just find out whether members know it. Take an example. When I have 1 out of 2 plus 1 out of 3, and I want to simplify, I can, okay, let me put here maybe 5, such that members don't think. I can just cross multiply. I multiply 5 times 3 plus I multiply 2 times 1. Then I come down, I say 2 times 3. Members, do we know that thing?
Yes.
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 Does everyone know it?
Yes.
Okay.
Yes.
Now, yes, allow me to do
Yes.
the same. Okay, allow me to do the same thing here. So I'll have 1 times sine squared theta, which is sine squared theta, plus cos theta times cos theta, which is cos squared theta. Out of down, I'll have cos theta sine squared theta. Members, are we on the same page? Are we there?
Yes, sir.
Teacher.
Okay. Should we continue, members? Now,
Yes.
you remember that sine squared theta plus cos squared theta. Members, what do we get?
1.
Yes. Now that is the application. 1 out of cos
Cos
theta sine squared theta. Now, once I reach here, I can separate. I say 1 out of cos theta times 1 out of sine squared theta. Then in my conclusion, I know 1 out of cos is sec theta. 1 out of sine is cosec. But since it is squared, it will be cosec squared theta. Members, let me know whether you have understood that.
Yeah.
Yeah. Has everyone understood?
Yes.
Yes. Any question? In case you feel you have a question, kindly ask. Yes, in case you have a question, kindly ask. When you finish, yes, please.
Meaning sin theta plus cos theta gives 1.
Yes, you're saying?
Sin theta plus cos theta gives you 1.
A sine squared. Sine squared
Yes.
must be squared, yes. That is the first identity we looked at. The whole of this is the 1. So for you, where you find it, you put 1.
Okay.
How did the cos squared theta go? Cos squared theta, I don't know whether how did the cos squared theta go? Yes, no, like here we have applied the identity that when I have cos squared theta plus sine squared theta is the same as 1. So for us where we have that, we shall put 1. Then, how did the cos come? Cos times cos is cos squared. 1 times sine squared theta is sine squared theta. Then we say the denominators, you multiply them. I don't know whether Timothy we're on the same page now. Timothy, let us know. And Aaron. Yes, Precious.
Teacher, my query is, when I'm using the left-hand side, do I need to also prove the right-hand side, or I just choose one of the two sides?
You choose one of the two sides, the easy one for you, proving. Okay. Hope it is fine, Precious. Yes, Nelly?
Sir, can you help us prove from the right hand side?
Yes. Now, when you are proving from the right-hand side, it requires you to have that deeper thinking. So when you are moving from the left-hand side, let me show you. From the right-hand side. Now, from the right-hand side, we have sec theta cosec squared theta. Now, this one, we know it very well that sec theta means 1 out of cos theta. And cosec squared theta means, let me put times, means 1
over
out
sine.
of, but sine squared what?
Theta.
So this one, 1 times 1 is 1 out of cos theta sine squared theta. Is that fine?
Yes.
But you know very well that 1 is the same as cos squared, okay, any. Sine squared theta. So you replace divide by cos theta sine squared
theta.
Now, once you reach at this point, you can separate. It's like when you are dealing with fraction, 2 plus 3 out of 5. You can say this is 2 out of 5 plus 3 out of 5. So here at this point, I'll say this is cos squared theta out of cos theta sine squared theta plus sine squared theta out of cos theta sine squared theta. Now, cos, since up there are 2 causes, I remain with 1. So it will become, I will cancel 1 and 1. So I remain with cos theta out of sine squared theta. Plus, here, sine squared will go. I remain with 1 out of cos of theta. Hope that is okay.
Yes.
Now, when I continue, here I can write this as cos theta out of sine theta times 1 out of sine theta, then plus 1 out of cos of theta. Cos theta out of sine theta is the cot theta. 1 out of sine is the cosec of theta, plus 1 out of cos is sec theta. So you get exactly that.
Oh.
So
thank you, sir.
Okay. So whatever hand you want, yes, whatever side you want, you can come. Yes, Angel.
Excuse me, sir. I beg your pardon for the third last step.
Third last step. Here, this one?
Okay. I can't see from there. Like, how do we get there?
How do we get there? Now I'm coming back from here. You had cos squared theta out of cos theta, sine squared theta. Now, Angel, I'm dealing with only this part here. What will happen is up cos squared theta means cos theta, cos theta. And when you look down, you have cos theta, sine squared theta. So this cos 1 and this one can cancel. So you remain with cos theta out of sine squared theta. Is that fine?
Thank you. Yes,
okay.
Please. Thank you.
Okay. Okay. Members, can we continue now? You can type in the chat, you can continue. Oh, yes, yes. And we continue.
Yes.
Okay. Now we are going to try another one. Another identity. So it is just a matter of us proving it. And just they play with your head to see whether you can come up with them. Another identity we are going to have sec squared theta into 1 plus sec squared theta is the same as sec squared theta minus cos squared theta. Now, when you look at that, you need to think. I have told you you can come from any hand of your choice, but always there will be a hand that is easy for you to come from. So not, sorry, this is sine, sorry, let me correct. This is sine, not sec. Sorry. This is sine. This is sine squared theta, 1 plus sec squared theta. Sorry. Now, when we are proving, we can start from left going to the right, or right to the left. So I can start from this side. So I know that when I open brackets, I'll have sine squared theta plus sine squared theta, sec squared theta. Members, is that step fine?
Yes, sir.
Okay. So we are going to continue and say that this is the same as sine squared theta plus sine squared theta. But I know sec. Sec means what? 1 out of cos squared theta. Members, let me know whether we're on the same page. Nelly, are we on the same page?
Yes, sir.
Okay. Okay. Now, what are you going to do? Sine squared theta times 1 means sine squared theta. So I'll have plus sine squared theta out of cos of squared theta. Now, the question is, what is sine squared out of cos squared theta, members?
Sine, it's tan. No?
Tan squared theta.
So I'll have sine squared theta plus tan squared theta. Are we together, members?
Yes.
Now, I'm going to take you back. When you look at our answer, we want sec, we want cos. There is nothing like us having what? Tan. Meaning, we must remove the tan. So you ask yourself, how is tan and sec related? Remember our identities. There is an identity we derived which had tan. Do you remember it, members? We said 1 plus tan squared theta, members, is equal to what?
Is equal to sec. No, sorry.
Is equal to sec squared theta. Now, since you have tan, and when you look at your answer, there is sec, meaning you must remove the tan. So to remove tan, I make tan squared the subject. So I'll have tan squared theta is equal to sec squared theta minus 1. Members, is that clear?
Yes.
Now, I'm going to come where there is tan squared, I put that. So I'll have sine squared theta plus sec squared theta minus 1. Is that okay? Anyone that is lost? Because we are proving. Should we continue?
Yes.
Kevin, first tell us. Kevin, first tell us.
Teacher, I'm lost.
From where?
Is this a continuation from the answer we got over another step?
Hey, this is another number.
Oh.
Hey, this is number 2.
Okay.
Okay. Now, when we look at what we are proving, there is cos, but in our answers, we have a sign. So you ask, how is sine and cos related? You go back to identities, that sine squared theta plus cos squared theta is equal to 1. So since you want sine away, you make it the subject. Members, sine squared theta will equal to what when you make it the subject?
1 minus cos squared theta.
1 minus cos squared theta. So you come where there is sine, you put that. So I'll have 1 minus cos squared theta plus sec squared theta minus 1. Techno, yes, tell us, Techno BF7. Techno?
I was telling you the answer.
Oh, okay, okay. Complete for us, Techno. I want you to look at this one and this one. 1 minus 1.
They cancel out.
They cancel out, eh? So we shall remain with negative cos squared theta plus sec squared theta. So you arrange it in the way they want it. So which will be sec squared theta minus cos squared theta. Members, let me know whether you have picked something. Angel, your hand is up. Angel, tell us.
Excuse me.
It's okay, I've seen it.
Oh, okay. There was someone else asking. Someone was asking, tell us. Okay. Okay. Kindly let us write. When you finish, you let me know. Sylvia, I'm not getting you. Sylvia, which part? Sylvia, unmute and you talk to us. Elijah.
Sir, the last part. The last
Which
part
one?
where there is sine squared, sine squared theta, where does the 1 minus cos squared theta come from?
Oh, it is an identity. An identity that sine squared theta plus cos squared theta, you'll get a 1. So since you don't want sine, you take the cos this side. So I will say sine squared theta. Since it is positive, once it crosses, it becomes a minus. So that's why you bring in 1 cos squared theta.
Yeah, thank you, sir.
Okay. When you finish, right, you tell me, and then we can look at another identity. And once you learn how to prove trigonometric functions, I'm telling you, you're going to enjoy paper 1 like a D1 in paper 1, because those are the main topics. Yes, Angel.
Okay, for the second last step, the 1 minus cos squared theta plus sec squared theta minus 1. Okay, can't we, why don't we, I don't get how we got the next step, because I thought we would like collect like terms and it would be, 1 minus 1.
It
Okay,
will be.
I've seen 1 minus 1 is 0, then the negative remains in the cos squared theta.
Okay, okay.
Yeah.
Yeah, okay. Okay. So members are saying we can continue.
That's right.
We good to continue? Okay. Someone is saying we continue. This is another number, please. So don't confuse them. This is another identity we are proving. Number 3. Sec squared theta. We are proving sec squared theta is the same as cosec theta out of cosec theta minus sine. Now I want to first invite you to try it. First try. Let everyone first try out this one and we see. Try it. So we are trying. I want to see people trying. Yeah, Peter Chiberu, we are advancing. We are advancing slowly. From there, we are going to prove those hard ones. So, but we start slowly and then we build. People are trying. I want us to think. Trigonometry requires a lot of thinking. You think, you think. Yes, Precious.
Well, teacher, my query is it always a must that the left-hand side will be easier than the right-hand side, or any side can be easier depending on the question?
Yes, it depends on the question.
Okay.
It depends on the question.
So, teacher, am I right? Am I right with this question that you've given us, number 3? Number 3 that you've given us. Sec squared theta. I've used sec squared theta equals to 1 out of cos theta times 1 out of cos theta. And I got 1 out of cos squared theta, giving me sec squared theta. Am I right?
You're on track. Continue.
Okay.
Points. Okay. Yeah. So, but at least I'm happy. People at least they have started to have that mathematical eye. That is a good sign. Now I'm coming in from that point where Precious. I'm starting from that where Precious has stopped. So, good. So we know that sec squared theta, like Precious has told us, is the same as 1 out of cos squared theta. Now, what should your mathematical eye tell you? That what they want, everything they want this side has sign. Meaning that this cos of yours, you must write it in form of a sign. So what do you remember? That cos squared theta plus sine squared theta is equal to 1. So what will my cos squared equal to? Cos squared theta will equal to 1 minus sine squared theta. So you come back here and say, this is 1 out of 1 minus sine squared theta. Hope members that is okay.
Yes, sir.
Yes?
Yeah.
Yes.
Now, you ask yourself another thing. Always look at where you are heading. That is the most important thing. Look at where you are heading. You ask yourself, what is cosec theta equaling to? Cosec means what?
Cosec means 1 over sine.
It's 1 over sine.
Cosec means 1 out of sine.
Sine.
Now, you ask yourself, here, when I look at where I'm heading, I have minus sine theta. But here, I have minus sine squared theta. You ask, can I be able to remove one sine from here? Or how can I remove one sine? Members, how can you remove one sine?
So you factorize.
You factorize. Okay, good. That is one. Now let me take you to some math here. In case I have 3 plus 4, something like that. Members, do you know that when I divide up and I divide down by the same number, I have not changed anything? Let me say I divide by 2 up, I divide by 2 down. What will I get? I'll set 2 out of 2 out of 3 out of 2 plus 4 out of 2. Members, is this fine?
Yeah.
It is the same trick I'm going to use. I'm going to remove one sine. So I can say 1 out of sine theta up, out of 1 out of sine theta minus sine squared theta out of sine theta. Members, let's digest that. Is that fine? I'm saying, when I look at where I'm heading, I have sine theta. So to remain with one sine theta, since these ones are 2, I must divide by sine theta. So the moment you divide up and down by the same thing, you remain with the same thing. Now, what is going to happen? Isaac Pastor. Isaac Pastor. Isaac. Prophet.
Teacher, what if you rush?
Yes? Ask again. Oh, okay. But I had something like rationalizing. But once you rationalize, here you may not get the answer. Reason being, you are going to end up with you are going to end up with some answer that will not be related to this. So rationalizing works, but it depends on the number you are dealing with. So 1 out of sine is cosec theta. Out of 1 out of sine, which is cosec theta, minus sine squared theta out of sine theta, you end up with sine theta. So that is how you can prove it. Yes. The last step. Yes, Angel. Angel, first come.
Teacher, I beg your pardon for why we divide throughout by sine theta.
Why? Now, this is what we had. We had 1 out of 1 minus sine squared theta. And where are we heading? We want something like cosec theta out of cosec theta minus sine theta. So when you look at the step you have reached, you can notice that here I have sine squared theta, but here I have sine theta. Then you ask yourself, how can I get sine theta? The easiest way to get sine theta, it means that since they are 2, I will have to divide by 1 sine. And the moment you divide everything. You divide up and you divide down. I don't know that, Angel, that is okay.
Yes, please, thank
you. So that's why we divided. So we divide by sine. Always, when it comes to proving, look where you are heading. Where you are heading should give you the direction. Okay. I want to give you one more. And then I leave you to do as many. So if by the end, yes, Peter.
Master, I've not seen it complete.
Hey, okay, we completed it from here. 1 out of sine is cosec. 1 out of sine is cosec. Hopefully you can see it now.
And go to the room. Go to the room.
I've seen.
Okay, hope we can continue. Yes. Here, don't forget you can start from any hand. Someone has, I think you can see Nicholas. Nicholas started from the other side and it came out. So do not mind. For you, any side you start with, you can come up with. That is good, Nicholas. Okay. Whatever side you come from, you'll get the answer. Okay. Now, allow me, I put one more. I want us to try. I think, like I've told you, we go on advancing a bit. Yes, then I'll give you very many numbers for you to try out. But let me start from here. 1 plus sine theta out of cos theta. Prove that is equal to sec theta plus tan theta. Let everyone start that.
Yes.
Please, in case your background is bad, so we are proving that. Everyone is trying. I'll be the happiest if everyone gets this number right. Hey, Peter, have you got the number correct? Hey, okay. Precious, have you got the number right?
Yes, I've tried. I've used the left-hand side, whereby I got 1 out of cos theta plus sine theta out of cos theta, since we have the same denominator, and I ended up with sec theta plus tan theta.
Okay, perfect. Hilda, hope you got the answer. Hilda? Is it Hilda man or Hilda, something like that? Oh, okay, okay. Yes, okay, that is good. At least now people have picked that one. We can now advance slowly. I'm going to put another one. 1. Now, when it comes to trigonometry, at times you'll find yourself even rationalizing. You'll find yourself rationalizing. I want you to try that one also. Yeah. Feel free to come from any side and we'll see. Any side of your choice. We are trying. Yes, Neddy?
Yes, I've got the answer.
Wow, perfect. 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 Where have you come from? Right, left?
I started from the left-hand side, where I first used the first identity to get 1 minus sine theta. I used 1 minus sine theta to be cos squared theta.
Okay.
So then I divided 1 out of cos squared theta plus sine theta out of cos squared theta.
Okay, perfect.
Yes.
Okay, I think some of you have tried, some of you have tried. Yes, so so we can proceed. Now, this is the first step. So for some numbers, you'll find yourself rationalizing. So when we rationalize means change the sign down. So I'll have now 1 plus sine theta plus 1 plus sine theta. I'll have 1 plus sine theta, everything squared. Divide by. Now here you don't want to go back to multiply the denominators, but I want to just use this identity that a squared minus a squared is a plus b, a minus b. So when you look down, you have 1 plus sine theta and 1 minus sine theta. So meaning when you multiply the numbers down, you'll have 1 minus sine squared theta. Because for this case, your a is 1 and your b is the same as sine theta. So when you put them here, you have 1 squared minus sine theta squared. So 1 squared is 1 minus sine squared theta. So what will happen now? Now, 1 minus sine squared theta, you need to remember your identities that cos squared theta plus sine squared theta is equal to 1. So when I take sine squared theta the other side, it means that cos squared theta will equal to 1 minus sine squared theta. So here, I'll end up with, my thing will become, from this step, it will be 1 plus sine theta, everything squared, out of cos squared theta. Members, let me know, are we on the same page? Are we on the same page at that point?
Yes.
Now, what are we going to do next? I have 1 plus sine theta, everything squared, out of cos of squared theta. Now, this down one, like when I have a number, let me say x squared out of y squared. These squares, I can put them into one bracket as xy, everything squared. So I can do the same here. I can have 1 plus sine theta, everything out of cos theta, but everything squared. So once I reach that point, what am I going to do? This cos theta, I can divide it and I say 1 out of cos theta plus sine theta out of cos of theta, everything squared. So what will this one yield? I know that 1 out of cos is the same as 1 out of cos is the same as having my sec theta plus sine out of cos is the same as having what? Tan theta, everything squared. So that is the answer they wanted. Are we together? So
Yes.
that's how you had to do it. Yes, Angel.
Excuse me, sir. For the okay, I thought when we rationalize, we multiplied both up and down.
Yes.
But first put back the second, the first screen rather, please up.
Angel, are you seeing there? We multiplied up and down.
Okay. Yes, there. It's like we only multiplied up. We did not multiply 1 minus sine theta times 1 plus sine theta.
Oh, Angel, we multiplied. We
Oh.
multiplied, though I used an identity, difference of two squares. But what you do, Angel, for you can do it yourself. You say 1 minus sine theta, 1 plus sine theta. Then you multiply manually. So you say 1 multiplies the 1. So this is 1 into 1 plus sine theta minus sine theta into 1 plus sine theta. So Angel, for you open your brackets, you'll get the same thing. Isn't it what you got?
Thank you. Yeah.
Yeah. So the moment you see 1 minus something, 1 plus something, and they are the same, that one just apply the difference of two squares. Has everyone finished?
Sir,
Yes.
is it okay if we use the negative on when we are rationalizing?
Where do you use the what? Where do you want to use the negative?
Because
now.
Yeah.
Now, when you are rationalizing, it's like, it means you conjugate. Conjugating means using the sign. Meaning changing the sign.
But
Changing the
if we
sign.
use the sign of the numerator.
When you want to, okay. Now, when we say rationalizing the denominator, it means we multiply the denominator.
Yeah.
Though that mathematics is also correct when you rationalize the numerator. It's not that always should be the denominator. At times you may find yourself when you are doing the other way around.
Okay, thank you, sir.
Okay. Finished? Members? Yeah. Okay. I want to put the very last one that we are going to prove. And we see, and once we finish this one, I'm going to give you very many numbers to prove, such that today when you sleep, when you have proved some numbers, you'd be a step ahead. And what are you proving? You are proving that it's the same as code. Though I want also to, you first try out. First try out and see whether things are coming up. So I think it is Hilda. So yes, Hilda, with mathematics, I'm telling you, it's one of the beautiful subjects, and it is always very, I don't know. Okay, to me, always, when I'm working out a number and maybe it fails to come out, it is hard for me to sleep. So I find myself working until when I get the answer. And those people are going to go into programming. You'll also find the same thing, that when you are programming a language and things fail out, you cannot sleep until when you find out the solution. So for me, I cannot sleep until when I find the solution to the problem. So please and please make sure the moment you do math, make sure you aim at you always finding the solution before you sleep. It will make you think critically. But I know at least if I give you 10 numbers and you are able to do 7, just know you are good with trigonometry. You do 7, even if there are 5, just know you are going to be very good. Okay, I know. Yes, Nelly.
So I have got the answer.
Wow. Okay.
Yes. May I start my working?
Yes, start and we hear.
So cot alpha. I used cos alpha out of sin alpha.
Okay.
Then tan beta. Sin beta out of cos beta. Divide by cos beta out of sin beta plus sin beta. Sorry, plus sin alpha out of cos alpha.
Okay. Before we continue, Nelly, I want to also Mary has got it. Perfect. Okay, good. Continue. Give us one step and Mary will come also.
So I got the LCM of the numerator, which was sin alpha cos beta.
Okay.
So the upper thing I got sin beta, sin alpha, plus cos beta, cos alpha.
Okay.
So divide by the denominator, which was sin beta, sin alpha.
Okay.
Plus cos beta, cos alpha. Out of sin beta, cos alpha.
Okay. You first pause and we see whether everyone will be on the same page. Members, are we on the same page? Are we leaving someone? Or also Stella got it? Members, are we on the same page?
No.
No. Which person are we leaving? Where are we leaving? Tell us the step where you are lost.
Start from the beginning.
From the beginning, Timothy. Timothy, hope you know that
Yes,
cot is the same as cos out of sine. You know that?
Yes, sir. Yes, sir.
You know tan is the same as sine out of cos.
Yes, sir.
Cot beta, same as cos out of sine.
I'm
Similar
getting.
in tan. So is this step fine?
It's fine, okay.
Now, when you reach here, cross multiply like we said. Multiply cos and cos. This is what is serving. Multiply sine and the other one. That's what is serving. Then multiply the denominators.
Okay, sir.
Okay, I saw Mary. Was it Mary that was second to get it? I wanted also to continue. Mary, continue from here.
I used the other way around. I used 1 over 10.
1 out of?
10.
Oh, okay. Mary, you're going to take us, no worries. Mary, you're going to take us through that, no worries. Okay. Nelly, let us complete.
So, sir, I went on to cancel.
Okay. This?
Yes.
Okay, this one's cancel.
Yes. Then the downer one also.
The downer one?
Yes, the downer one. There's sine beta, then there's sine beta up. Then cos alpha and cos alpha also cancel.
So you remain with?
I remained with sine beta plus cos alpha.
I'm not seeing which one cancelled.
I cancelled sine on the numerator. I cancelled sine alpha and sine alpha. Then cos beta and cos beta.
Now, remember, I'm seeing this. After cancelling then this what you remain with?
So can you scroll up?
Oh, okay, I'm going to scroll. What do you remain with? Isn't it this?
No. Okay, that I never used that method.
Oh, okay.
Yes.
I was writing what you were telling me. Which method now did you use?
Okay, where you stopped using a blue marker here.
Hey.
Yeah, I think I should give you the step I have here.
No, I want you need to move from that step that you gave us.
So for the numerator, I first dealt with the numerator.
Okay, I think I've seen. Now, here, these are the ones that cancel.
Yes.
These ones, eh?
Yes.
So you remain with 1 out of sine.
So is it going the right way?
Yes?
Because when you cancel, you remain with only the denominator.
This is what you remain with. Remember, you cannot cancel these ones. This is sine beta, this is sine alpha. Have you seen the difference? But the numerators for both the denominator and the numerator, these ones are the same, sine beta, sine alpha. So they can cancel. But these ones down, they can't. So once you reach here, you just get the reciprocal. I think that's what you had.
Yes, sir.
So it comes out. Sine beta out of cos is the tan beta, then cot alpha. Okay, thank you. That is okay. That is one approach. Mary, can you take us through yours?
Yes, sir. Can I begin?
Yes.
Since that we know that cot is the same as 1 over tan. First of all, I have used the left-hand side. So I say 1 over tan alpha plus tan beta. All over 1 over tan beta plus tan alpha. Then I factorized.
Okay.
On the numerator side and the denominator side. So tan is common. I put it outside.
Okay.
Tan into 1 over alpha plus beta.
Tan into 1 out of?
Alpha plus beta. All over tan into 1 over beta plus alpha.
Okay. Now, let me start from that point. Now, Mary.
Yes,
you
sir.
had moved well, but an angle can never be separated. An example, Angel, sorry, Mary, when I have
Yes, sir.
cos of 60, can you be able to factor out of 60 and say remain with cos? Do you think it can be
No.
possible? Yes. So an angle, that alpha you are seeing is an angle. So you cannot separate them. But I want us to continue with this approach. It is leading us to the answer also.
Okay, sir. Thank you.
Mary, we are continuing with you. I want you to just get the all same. Continue. We have to do it. Tell me. Mary.
Yes, sir.
I want you to cross multiply. I want you to deal with this one first. 1 out of tan. I want you to simplify it. Plus tan beta. In simplified form, what do you get?
Tan beta over tan alpha.
No, okay. Are you saying what is the LCM?
Tan alpha.
Tan alpha is the LCM. So what shall we remain with up?
1.
1. Good.
Plus tan alpha beta.
Tan alpha tan beta.
Yes.
Now we come to the next one. 1 out of tan beta plus tan alpha. Mary, we continue. What shall we remain with?
1 plus tan alpha tan beta out of all over tan beta.
Out of tan beta. Now we are going to substitute.
Yes, sir.
In the numerator, we put that. So in our numerator, we have 1 plus tan alpha tan beta out of tan alpha. That is the numerator. Divide by. In the denominator, what do we have?
1 plus tan alpha tan beta all over tan beta.
Out of tan beta. Okay, good. Now, are you seeing something's crossing? Okay, we can do it this. So this means 1 plus tan alpha tan beta divided by tan alpha divided by 1 plus tan alpha tan beta out of tan of beta. Is that step fine? Prophet Emma, first come in before we...
It's fine, sir.
Okay. Now, once we reach this step, we take the reciprocal. So we shall have 1 plus tan alpha tan beta out of tan of alpha times tan beta out of 1 plus tan alpha tan beta. Mary, are we still together?
Yes, sir.
Complete your answer. What are you noticing?
1 plus tan alpha tan beta in the numerator is the same as 1 plus tan alpha tan beta in the denominator, so they cancel.
So what shall we remain with in the numerator?
Tan beta divided by tan alpha.
Now, you tell us from here, what is 1 out of tan alpha equaling to?
Cot alpha.
Cot alpha. So our answer will be tan beta cot alpha.
Thank you, sir.
Okay, thank you too. Yeah. So that is the second approach. So for trigonometry, we don't have one approach. Okay. Yes, Peter.
Master, I'm seeing the end, but I've not understood somewhere.
Where?
Because I see that 1 plus tan alpha plus, tan beta out of tan alpha divided by 1 plus tan alpha tan beta out of tan beta. So if I'm to cross out the tan alpha and the tan beta on both sides,
Hmm.
I see if I will remain with 1, right?
Mm-hmm.
If I
Have you
add
done
that,
it like that? Like this?
I'm not seeing well. Yeah.
Yeah?
Yeah.
Did you want to get the reciprocal?
Yeah, the reciprocal. Yeah, I got it.
So in the numerator, it remained with tan beta.
Yeah.
And the denominator, it remained with tan alpha.
Yeah, +1.
+1 from where?
No, here, I'm saying here in tan beta.
Okay, yeah. But now these two are the same. When you look here and here, so they can cancel.
Oh, yeah.
They are the same, so they can cancel out. Hope it is okay. Okay. So finish. I want to remove the screen and I get the numbers I want you to try out. So allow me to first stop the sharing and I get for you the numbers I want you to try out. So make sure before you sleep today, you have tried out at least 5 of them on your own. And once you prove, even you can come to my inbox and you say, I have proved them right. Yeah, so that would be the best. At least you know that you have done something very constructive at the end of that day. Yes, so trigonometry, make sure you practice as much as you can. As much as you can. And the moment you some identities are very easy. I think I promised you very many identities.
Yeah.
Yeah. Fact, let me give you very many, as many as I can. Are you saying you're going to screenshot? Are you saying
Excuse
the
me, sir.
exercise? Yeah.
Excuse me, sir.
Yes, please.
Sir, may you please take the screenshot for us because I don't know how to screenshot using a laptop.
Oh, which laptop are you using?
Lenovo.
Lenovo. Okay. I'm going to share them in the group. But those who can screenshot and you share with us.
Okay.
Finish to screenshot?
Yes.
Okay. Are you seeing other identities? You tell me whether you finished. Finished? Let me hope people have finished. I have told you I'm going to give you many, but it shouldn't scare you. Don't get scared. Don't get scared. Don't get scared. I'm finalizing the last lesson. I'm going to call you.
Teacher, can you first go back to the last?
There?
Okay, thank you.
Okay. Those who have not got them, I'm going to share them in the group. I'm going to share them in the group, and then I'll ask you to try out. Yes, I'm going to share very many, and then I ask you to try out as much as you can, such that when we reach solving, they can become very easy. Otherwise, I want us to end here, unless someone has a burning question, and then I wish you a good day. Yes, in case you get some challenges, feel free to inbox me. You can send me a message on the WhatsApp, much as I may take a bit long to reply, but once I see them, I'll reply. Okay, have a good evening, everyone. I'll share those questions in the chat for those who don't have them. Yes, Peter.
Excuse me, sir.
Yes.
I just wanted to inquire about other subjects not being on a timetable.
Like which subject?
Like ent.
Okay, ent.
Yeah.
Okay. Noted. And okay, now we would love to have all those subjects, but some of our teachers that are supposed to be teaching are away for a workshop. That is one of the challenges. I think I will first run a survey to find out how many ENT students are around. In case there are many, then we can get another teacher to help as we wait for him to come. But I will first find out how many ENT.
Excuse me, sir.
Yes.
Sir, for me, I'm thanking you for what you've done.
You're welcome. Okay. Thank you so much, everyone. Have a nice evening. Yes, biology is going to happen. We shall have biology. Okay.